In this lesson, we're going to learn how to graph a compound inequality on the number line. And when we think of a compound inequality, we're going to think of the word and or. So in each of the problems, we're going to look at examples that uses the word and examples that uses the word or. So the following examples are going to be basic examples for this objective in order the objective which is graphing a compound inequality on the number line. All right, so for example, let's start up with the first one. So let's suppose the first one we had this inequality, x is less than -3, all right? And then the word or, and then this inequality, x is greater than or equal to 0. All right, so what makes this a compound inequality is that you have two simple inequalities with the word or. And so basically to solve this compound inequality, we're going to look at each of the solutions on the number line. So the approach is to look at the number line for each of those. So for example, let's look at the solutions to this inequality. Now notice that this inequality that I'm circling right here, the variable is already by itself. So the solutions to this inequality right here that I'm circling is any real number that's less than or equal to -3. Now to graph that, let's go ahead and put -3 on the number line. And remember, we could use an since there's an equal sign, we can use a closed circle or a bracket, does not matter. So I'm going to use a closed circle. And I'm going to shade every real number to the left. Okay, now what I've shaded, keep in mind that what I've shaded is the solution to this inequality right here. So notice everything, every real number less than -3 satisfies this inequality right here. So for example, -6 is in the shaded region. -6 is a solution to this inequality because -6 is less than or equal to -3. All right, now let's look at this one. All right, so let's look at this inequality. So I'm going to do a different number line right here, and I'm going to put 0 right here to help me think about this. So here's 0. I'm putting 0 because this is what you see here. And I want to, and the solutions to this inequality is any real number that's greater than or equal to 0. So greater than or equal to. So notice it says equal to, so I'm going to put a closed circle or a bracket, does not matter. And I'm going to shade in every real number to the left. I'm sorry, to the right. All right, so any real number to the right is a solution to this inequality. All right, now what I want to do though is graph the solution to this compound inequality. All right, so that's where we look at the word or right here. So or. Now what or means is this. The solution to this compound inequality is the solution to this inequality or the solution to this inequality. So any solution to this is a solution to the compound inequality. Any solution to this is a solution to the compound inequality because of the word or. So the solutions will come from either this or from this. So to solve a compound inequality, to graph a compound inequality, you're going to look at every part of those inequalities that are shaded in. And so therefore your answer in terms of the graph will be this. So basically you're going to combine those two into one graph. And so your answer is going to be, make sure you put those numbers in numerical order. So -3 is going to go on the left, and then 0 is going to go to the right. All right, and so you just shade in what you see. So remember, x is less than or equal to -3, so closed circle to the left, and then x is greater than 0, closed circle to the right. All right, and that's it. So that is how you graph a compound inequality in the number line. So notice that this is your answer. So any area of the number line that's shaded is a solution to this compound inequality. So this part satisfies this part satisfies this. All right. Now, they didn't ask you this, but this is going to be important at some point. They're going to ask you to write this in interval notation. So interval notation, that's where you use parentheses and brackets. And you always go from left to right. So notice that as you go from left to right, you see this arrow? This arrow is pointing towards that idea of negative infinity. So I'm going to go, and whenever you deal with infinity and negative infinity, you always use parentheses. So parentheses, negative infinity to -3 with a bracket. Okay, bracket because of that equal sign, -3, closed circle, -3 is a solution. Union, so the word U right here, or the letter, the symbol U, and then union from bracket 0, bracket because of the equal sign, all the way to positive infinity. And so that's your solution in interval notation, and that's your solution as a graph. All right. So the word R means any part of the graph any part of the number line that's shaded here, or any part of the number line that's shaded here is a solution to the compound inequality. So notice your final answer on one number line, is you transpose this here, transpose this here. Okay. All right, so let's go to number 2. Number 2, we have this. We have x is greater than equal to -4, and, so now I'm using the word and, so that's a different notation. And x is less than 6. All right, so x is greater than -4, and x is less than 6. So I'm going to do that same idea that I did here. So I'm going to put these on 2 separate number lines to think about this. All right, so let's go ahead and graph that first inequality since x is already by itself. So I'm going to go ahead and graph this. So here's -4. Notice there's an equal sign, right? So I'm going to go ahead and use bracket or closed circle, does not matter. I used closed circle in the previous one. We use bracket here, does not matter. And then I'm going to shade in every real number to the right because it says x is greater than or equal to -4. So any part here that's shaded is going to be a solution to this inequality that I'm circling right here. Then let's go to the next one. So I'm going to do a separate number line. And then 6, make sure you put 6 in the correct spot in relation to -4. So we know that 6 is to the right of -4, so make it look like it's to the right of -4. And then I want to shade in every real number that's less than 6. Notice there's no equal sign, no equal sign. Since there's no equal sign, you're going to use parentheses. All right, parentheses or open circle, and then going to the left. All right, so you're going to shade in every real number to the left. All right, now let's think about the word and. And means this. And means this compound inequality with the word and means this. The solution to this compound inequality will be the solution that's here, and at the same time, the solutions that satisfies this. So I want the solutions that satisfies this and this at the same time. So what I'm looking at here is the intersection of those two graphs. So if you look at those two graphs, and that's why I asked you, make sure you put those in relation to each other. -4 is to the right, to the left, 6 is to the right. And then the intersection of those two. So that's where the two graphs intersect. So therefore your answer will just be what's shaded. So you have -4 and 6. So you can put -4, 6, and then notice we have a bracket at 4, and we have parentheses at 6. And so here's your graph. All right, so there's your graph. In terms of open and closed circle, you would say this if you wanted to put open and closed circle. So here's -4, here's 6. Closed circle, make sure it looks closed. Open circle, make sure it looks open. And then shade in every number between them. Okay? All right, so there's the graph. So that's what an and inequality means. An and inequality means you're looking at the intersection of the two graphs. Intersection of the two graphs. So what they have in common in both of these solutions. So solution here, compare them. What they have in common is a solution to this compound inequality with the word and. So and means intersection. R means union. So union means you're going to take what's shaded here and what's shaded here. You're going to put those two graphs together. Okay, now in terms of interval notation, let's talk about this in terms of interval notation. Interval notation. So you read a graph from left to right. So as I go from left to right, I'm going from -4 to 6, right? So -4 with a bracket because of the equal sign. So -4 bracket, comma, all the way to 6 with parentheses. And there's your answer. All right, so that's number 2. So it's not difficult, right? So R means union, and means intersection. All right, let's look at number 3. So in number 3, we have this. We have x is greater than or equal to -3, and x is less than or equal to 5. So x is greater than or equal to -3, and x is less than or equal to 5. And so notice the word and. All right, the word and. So remember, and means intersection. And so if you're going to solve this compound inequality, you want to find the solutions that are here and the solutions that are here and what they have in common. What they have in common because of the word and. So let's graph each one individually. So here is -3. And there's an equal sign, so I'm going to use bracket or open or closed circle. Does not matter which one you use, bracket or closed circle. But you're going to shade in everything to the right. So everything to the right that's shaded, including -3, is a solution to this inequality right here. If I look at this one, and make sure you put 5 to the right side in relation to -3. So here's 5. Equal sign, so closed circle. And so I want to shade in every real number that's less than that. So every real number that's less than that. Now remember, this is and. So the solution to this compound inequality will be the intersection of those two individual graphs, what they have in common. And so therefore your answer in terms of closed and open circles will be from -3 to 5, closed circle on both, because they're both are solutions because of the equal signs, and you shade in every real number between them. In terms of interval notation, you're going to say bracket -3 to 5, bracket. Always go from left to right, smallest to largest, left to right. All right, so that's number 4. So remember, and means intersection, R means union. All right, number 4, let's suppose in number 4, I had x is less than or equal to 4, or x is greater than 6. So notice this time I have an R, right? So an R compound statement. So R means union, U-N-I-O-N, union, and means intersection. So basically you're going to graph each of those individually. So you're going to if you do 4 first, so you're going to put bracket, and then you're shading everything to the left. So you're going to put the bracket pointing to the left, and you're going to go and you're going to shade in everything like this. And then the next one is 6. Remember, put 6 in relation to where 4 should be on the number line. So here's 6 to the right. And parentheses or open circle. I'm going to use parentheses here, going to the right. So I'm shading in every number greater than that. Now remember, union, R means union. So any the solution to this compound inequality would be any solution you see here and any solution you see here. So here's your answer. So your answer in one number line, here's 4, here's 6. So you're going to say, you're going to shade in you're going to shade in 4 and everything going to the right with a bracket. And then parentheses, make sure it looks like parentheses, and then going to the right. Okay? And so there's your answer. In terms, now that's the answer in terms of a graph, right? In terms of interval notation, now notice, see, you have two intervals right here. So you're gonna say -infinity to 4 with a bracket, -infinity to 4 with a bracket, union, and then parentheses 6 to infinity, parentheses. So whenever you deal with infinity, negative infinity, you always put parentheses. That's important to remember. Don't put brackets here. Never put brackets with parentheses, with infinity and negative infinity. All right, that's number 4. It's not difficult, right? Fairly simple process. Fairly simple process to deal with. Okay, number 5. So let's suppose in number 5 I had x is less than 4 and x is greater than 1. X is less than 4 and x is greater than 1. So remember the and statement. So that when you think of and, you got to think of intersection, right? Intersection. All right, the way I would do this is I would graph each one individually. That's the way you need to think about this. So let's graph this one first. X is already by itself. So when I look at 4 right here, and notice there's no equal sign, so I'm going to use open circle or parentheses. Does not matter. Just make sure it looks like an open circle. And you're going to shade in every real number to the left. All right, and then over here, here is 1. Make sure you put 1 in relation to where 4 is. So 1's to the left of 4. And open circle. And you're going to shade in everything greater than that. So it'll be like this. But remember, that's an and statement, right? So the solution to this compounding inequality will be what those two solutions have in common, the intersection. So at this point, I would shade in what they have in common just like this. Shade it in, it helps. And so therefore your answer on one number line will be from 1 to 4, 1 to 4, open circle or parentheses. Does not matter which one you use, but both of them are open circles. And there's your graph. All right. And so interval notation, you're going to say parentheses 1 all the way to 4 parentheses. And so that's the answer there. All right. Number 6. Number 6, let's suppose we had x is less than or equal to -2 or x is greater than 4. X is less than -2 or x is greater than 4. So again, notice the compound statement with the word or. So that's the word or. Remember, or means union. Or means union. All right, and let's go ahead and graph each one individually. That's the way you want to approach this. So here's -2. Less than or equal to, notice the equal sign. So -2 has to be included. So we're going to use brackets and pointing to the left, just like this. Okay, and then x is greater than 4. Here's 4, parentheses, pointing to the right. Oops, I meant to use a, sorry. I meant to use a different graph because I'm going to keep it consistent with everything else. So here's 4, pointing to the right, parentheses. And then remember, R means union. So anything that's shaded here and anything that's shaded here is a solution to this compound inequality. And so your answer will be these two regions that are shaded on the number line. -2, 4, bracket pointing to the left, and then parentheses pointing to the right. And so so in terms of interval notation, now there's your graph, right? That's the graph. But in terms of interval notation, you're going to say, see, it's pointing to -infinity, this arrow. So you go from -infinity to -2. -infinity, make sure it looks like an infinity symbol. -infinity. So remember, the infinity is like 2 zeros attached to each other. So -infinity to -2 with the bracket union, and then parentheses 4 to infinity. Okay? All right, that's number 6. Let's look at number 7. So it's not difficult. Very simple process, right? Very simple to deal with. All right, number 7. Let's suppose we had x is less than or equal to 6 and x is greater than or equal to -1. So x is less than or equal to 6 and x is greater than or equal to -1. So notice the word and, so think of intersection. So let's graph each one individually. So here's 6, and then I've got to shade in every real number that's to the left because it's x is less than or equal to 6 with a bracket, just like this. All right, and then the next one. Here is -1. Make sure you put -1 in the right place in relation to where 6 is. So it's -1's to the left of 6. Greater than or equal to, just like this. And then remember, you're dealing with and, so the word intersection. So you're looking for every real number they have in common. So your answer in terms of a graph is this, -1 to 6. So -1, 6, bracket going to the right, bracket going to the left, and you shade in every real number just like this. And so your interval notation will be from bracket -1 to 6 bracket. So remember what you shaded. Just keep in mind what you shaded. So your final answer, when you shade in your final answer, those are solutions. Those are solutions to that original compound inequality. So any real number in here will satisfy this. So for example, let's just think about this. Do y'all see that the number 2 is in here? 2 is shaded, right? So is 2 less than or equal to 6? Yes. At the same time, is 2 greater than or equal to -1? Yes. So any real number in here is a solution to this compound inequality. So if you look at the previous one, for example, so you see the number 7 is in this part, right? So the number 7 is this part. So here's the question. Now let's think about this. So remember, your this right here, this graph represents the solution to this compound inequality. So if I pick 7, I'm going to ask this question. Is 7 less than or equal to -2? The answer is no, right? 7 is not less than -2, but is 7 greater than 4? Yes. So 7 is a solution to this compound inequality because it satisfies either this one or this one. See that word or? It's just got to satisfy one of those, either this one or this one. All right. Now, if you look at, let's say, this one here, so y'all agree that -4 is in here. So is -4 greater than 4? Nope. But is -4 less than or equal to -2? Yes. So that's why it's a solution. So any number here or any number here will satisfy this compound inequality. Okay? All right. So that's an OR statement. So an OR statement means it's either got to satisfy this one or this one. So this one right here is this, and this right here is this. Whereas with an AND statement, your solution has to satisfy both of those. So that's why we're looking at the intersection. All right. So for example, the number 8, eight's not shaded, right? But I'm going to ask you this: is 8 greater than or equal to -1? The answer is yes. But why is it not shaded? Because of that AND statement. It's got to also satisfy this. Is 8 less than or equal to 6? No. All right. So there's a difference between the word and the word or. Okay. Or means it's got to satisfy either of those. The word and means it's got to satisfy both of those at the same time. That's why we look at the intersection. All right. Let's do one more. And I think you should be fine with this objective. So with the idea that compound inequality. So let's look at one more. So we have x is less than or equal to -4 and x is greater than -7. All right, so x is less than or equal to -4 and x is greater than -7. So notice the word and, so think of intersection. So what that means is this: when you find that solution, it's got to satisfy both of those. All your solutions has to satisfy this one and this one also. All right. So let's look at each one individually. So let's do this one first. So here's -4 and bracket pointing to the left because it says less than or equal to, and bracket because of the equal sign, right? Now, make sure you understand that -7 is going to be to the left of -4. So make sure you know that. -7 is to the left of -4 in the number line. There's no equal sign, so we're going to use parentheses and then going to the right. All right, now remember, that's an AND statement. So the solution to this compound inequality has to be what they have in common, hence the word intersection. And so therefore your answer will be from -7 to -4. -7, -4. And so I'm going to put open and closed circle here. So I'm going to put open circle, see parentheses, so I'm going to put open circle on -7 and then closed circle on -4 and shade in everything between them. And so there's your graph. That's the graph here. In terms of an interval notation, You're going to say parentheses -7, parentheses because of the open circle, all the way to -4 with a bracket, bracket because of the closed circle. So -7 is not a solution, but -4 is. So -7, whenever you see an open circle, that -7 is not a solution. Whenever you see a closed circle, that is a solution. So -4 is going to be a solution. All right. So for example, let's look at -4. So -4 is a solution, right? So and remember that and statement, -4. So is -4 less than equal to -4? Yes, it's equal to. Is -4 greater than a -7? The answer is yes. But let's see why -7 is not a solution. Is -7 less than equal to -4? The answer is yes. Is -7 greater than -7? No. -7 is equal to -7. So that's why you put parentheses here or an open circle in the number line. All right. Okay. So that is the objective on graphing a compound inequality on a number line.